Let's take a look at the very simple model algorithm. The first one is what we call linear regression. Mandarin 它就是线性回归嘛。Let's take a look at this figure. That is x. That is y. That is x. That's very simple data. So we have only one feature. We don't have n feature. We have only one feature. And y is right here. For example, we have 20 data points in this figure. If we plot all those data points in the surface, human beings are very smart. So we can see that, okay, those blue data points, they are very close to this orange line. The very first model creation algorithm is called linear regression because human beings believe lot of things in the real life, we believe the relation between the things are linear. For example, your height and your weight. Okay, if we collect all the students' weight and height, okay, and we plot this information, this data in a 2D surface, and maybe you can draw a line which describe the relationship between your weights and height by using a very simple line. Okay, and in high school, if you want to describe a line, we only need two parameters, okay, which is y equals ax plus b, right? A 就是斜率嘛，对不对？ slope. B is right here, 就是截距嘛，截距。So the model is like that. We have a model, right? We have a goal. We want to use x, which is x1, to describe the relationship. For linear regression model, ax plus b to y. So in this case, we only need two parameters to describe this perfect line, which is the orange one. There are several different lines. For example, this one, the blue one, okay? The green one, this one. Because human beings are very smart, so we know the orange one is much better than the blue one and the green line, right? So how do we find this best? Okay, what do we call best? Orange line, okay, to use it right here to describe this data. So you can see that for this very simple model, we only need two parameters to describe this line, rather than use a 20 data point and each one has x and y. We only use two variables to describe this line, rather than use 40 variables to describe the original data, which is much efficient, right? Although this orange line is not that perfect. For example, right here, this point, this data point, okay, this data point D, the actual point is right here, right? But when you input, for example, that's x1, y1, okay, this data point. However, if you input your x1 into this linear regression model, the y hat it output is right here. For example, y hat is right here, but the actual y is at the orange point, right? If you use the orange line to describe the original data and you input x1 into this line, and the y hat is on this line, which is correct. But however, for this data point, exactly the y1 is right here. It has a small difference between y hat and the actual y, right? So the difference is right here, the dot one. So as we can see that there are several differences. Okay, for example, H1 you can draw the difference right here. The actual y hat, the actual y hat. So you can draw all those differences. Human beings are very smart. So how do we know this orange line is the best line, not the red one? Usually when we want to evaluate two different linear models, for example, the orange one, we will calculate the difference between y and y hat. So all the things are right here. Y and y hat, y and y hat, y and y hat. And with summation, all those differences. So basically it looks like we summation all the difference between y and y hat. Okay, so the I is from 1 to n, so it's 1 I. With summation, the absolutely value 就是绝对值哈 value of y and y hat. Okay, so we can come up a measurement 就是一个评估啊 a measurement. So make sure we understand the difference between the model and the real data. So if you draw another line right here, so that is your model 2, calculate the difference. Okay, as you can see, the difference is much larger than the orange one, right? So we use a very simple mathematical function. Okay, we say a function. We usually use a very simple function, which is the difference between y and y and summation of them. So maybe you can divide it by n. So we can calculate a number. What is the average difference between y and y hat, the absolute value of y and y hat, to measure different model? Okay, so basically it looks like this: the n sigma I 1 to n, right? Y hat. So what is y hat? Y, as we mentioned, m1 is x2 y hat, right? So the y hat 1 is ax1 plus b, right? Okay, have a subscript 就是有个右上角有个标记那表示你是 M1 model. So of course, for the orange one, okay, for orange one, we can have this similar A2, okay, x1 plus b2 minus yi, and then this is from your model 2, is model 2, and our green one is model 1. So you can compare these two values. Okay, the smaller one is the better model that we use. This concept is very simple because maybe you have learned those in high school. So like this. Okay, so the question is, how do we identify the best model to represent those data points? In this purple one, okay, we call it L1 loss function. It has a name, L1 loss function. There's another one which we use more frequently called L2 loss function. It has another name called mean square error. When you see that L2, right, there's a 2 right here. So you write a 2, power 2 right here. So that becomes L2 loss function. So when we talk about mean square error or L2 loss function, what exactly we are looking for? Square error, okay, square error means the difference right here, okay, difference right here, okay, that is the difference, right, between y and y hat, right? And because there is a power of 2, right, so that is a square. In L2 loss function or MSE, we are seeking for the summation of the difference between y and y hat square, which means the area of this rectangle. Okay, so with summation of those square, we want to know what is the smallest area, 就是最小的面积 smallest area of to evaluate this model. Okay, if the area is smaller, then we consider the model, the orange line, is much better than the other one. Okay, if you have another model which is a little bit crazy like this, okay, the square right here would be very huge, right? So that is how do we measure different models. So the next question is, how do we quickly find out the A and B parameter, the best regression line? Okay, so let's take a look. Create some sample data, okay, which is right here, and it looks like this one. So basically, okay, we can see that might be proper 它很适合 to use linear regression to describe this data between its x and y. Okay, this is x, that's y. So the definition of mean square error is right here, exactly the same as I wrote before. For this model, okay, ax plus y, that is a linear model. However, for sometimes, okay, sometimes our data may be like this: x1, x2, xn, and y, right? Sometimes like this. So we can use this general form, 就是一般式嘛 general form to describe a multi-feature data, to describe this multi-feature data, okay, by using linear regression, okay. So sometimes you can use another form like y plus ax1 bx2 plus cx3 blah, 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 and xn. Or even sometimes we have another z, sometimes like that. You can use a general form to describe something. Linear regression is not necessary to be only x and y. You can have a lot of different features. So that is called MSE, mean square error. And there's another root, MSE. R stands for root. 所以就开根号哈 root. So you simply just root the MS value, okay? And here's the L1 loss function, okay? It's absolute value, 就是绝对值，没有平方。But what is the difference between using MSE, L1 loss function and L2 loss function? Both function is very reasonable to figure out which model is better. Okay, no matter you use an absolute value or use a square value. But what is the difference between using L1 and L2? As you can see that, right, that is ax plus b minus y and I, right? Okay, basically it looks like it. But however, this one is much more simple, right? Okay, so basically we are trying to compare what is the difference between this one and this one. Okay, theoretically, okay, just simply take a look at this. Look at x. Okay, x right here, and x is right here. Okay, you can see that in MSE, x is powered by 2, 就是 x 是有2的平方的。But in L1, x is simply just a variable, right? 就是一个一次方的嘛，就是一个一次方的。When we try to figure out what is the minimum value to compare different models, what we are trying to figure out, we are trying to figure out the minimum value of different models, right? Different models means their MSE value of model 1, MSE value of model 2, plus MSE value of model whatever, right? To compare different models, we are trying to figure out what is the minimum value among all those models, M1, M2, M3, so on and so forth. When we want to try to figure out the minimum value, the most convenient way is to do the differentiation, 就是微分呐，对吧？我们现在要找最小值嘛。In order to find which one is the minimum, has the minimum value, we can differentiate, 就是微分它。That is MSE, okay? MSE. If we try to differentiate, 就是微分的时候 we can see that because this value, okay, this formula of this value, it has a power 2 right here. So basically, it is a curve. 因为它有2次方嘛，对不对？所以它就一定是一个抛，就是那个曲线嘛。Because it is a curve, so it has a minimal value. 所以你微分它的时候，你一定可以找到最小值。Because it is a curve, so when you differentiate, it has minimum value. When you differentiate it, if it equals to 0, 就是微分等于0的时候。However, if you find an L1 function, because L1 function has no power of 2, 因为 L1 function 是一个一次式嘛，对不对？So Of course, it has minimum value, but the curve looks like this. It is not a curve. It is just two lines they concave with each other. So it cannot be differentiated， 就是它是不可为的。它是绝对值嘛，所以它是对称的。它有最小值，可是它不可为。不可为你就找不到最小值，你必须用一些逼近法。Okay? Because it is the definition of a one function contains an absolute value, so it cannot be differentiated. Of course, it has a minimum value, but you have used another approach to find such kind of minimum value. No matter if theoretically or in practical, we like to use MSE as our function to measure which model is the better model, because L2 function can be differentiated and you can find the minimum value. So there's always a star, okay, A star plus B star. Star means this is the optimized value. You can always find a model which is called M star. M star has two values, A star and B star as parameter. Okay, they use A star and B star to describe a line, and this line has minimum MSE value because you can differentiate the MSE value to figure out which A star and B star can make this value very, very small when you apply training data. A star xi plus b minus y hat star squared. You can always find A star or B star to figure out. When you apply all the data, for example, 20 data, as I mentioned, as we showed you before, there are 20 data points. Input all those 20 data points as xi, x1, y1, x2, y2, x3 to x20, y20. You can apply those data in this formula. And you can always find the best A star and B star to make this MS value to be the smallest one. So it is an optimized A star and B star. And that is the optimized M star, which is the best model. Okay? But you cannot do this for by using L1 because L1 cannot, this function cannot be differentiated. Make sure you understand all those things. So basically, L2 function is the one we use to evaluate different model, which is much better than L1. Okay. Penalty. What does the penalty means? If we use A value and a B value to randomly select A value and B value, and to create a model, a random model M. The M may be right here. Okay, its MSE value might be right here. The difference between y and y hat, when it is 5,000, it is right here. If you use L1 function to evaluate a random model, okay, the best model is right here, and your random model is right here. The difference between your random model and the best model, okay, the difference is 5,000. However, your L1 loss, the difference between you and your best model is 4,000. But right here, it is simply just right here. When you draw the slope, 就是你画那个斜率的时候, you can see that if your model is far away from the best model, okay, the slope is larger. 好，中文再强调，当你画这个斜率离你的最佳 model 越远的时候，你的学历就越大，对不对？因为它比较陡嘛，对不对？ But when you use L1 model, your slope is always the same. 你当用 L1 的时候，你在选的模型的时候，你的模型如果离你的最佳模型有点远的时候，你的学历不管怎么样都是一样的嘛，因为它是绝对值嘛。So when you do the differentiation, 所以当你做微分的时候 because the slope is larger, 因为斜率比较大，所以你就可以比较快的收敛到下面去。大家知道这件事情吗？你 x 每走一格的时候，因为你斜率比较大，你 y 走的格数也比较大，对不对？好，这是斜率代号。这个斜率一样嘛，所以你每次 x 走一格的时候，你 y 走的格数是一样大，因为它斜率是一样的嘛。 对不对？所以呢，当你在寻找最小值的时候呢，用2次式会比较有效率。When you use L2, because it's a curve, the slope it changes all the time. When you want to find the smallest value of y, it is more efficient to use L2 function because its slope is larger when you far away from your best model. The slope is smaller when you close to the best model. However, when you will use L1 to find your best model, no matter where you are, you always use the same pace to approach the best model, which is not that efficient than using L2, those functions. So use L2 to find our best model.